Hey guys, this is question number 13. So let's see what we have to solve in this question. So in this questions, it is written a beam of light of intensity I naught is equals to 120 watt per meter square is incidence on an optical system as shown in the figure, where BS1, BS2, BS3 and BS4 are identical 50-50 beam splitter, and I1, I2, I3 and I4 are the total intensity measured by the detectors. So we have to write what will be the value of intensity I3. That's mean what will be the intensity that will be measured by the detector detector 3. So to solve this problem, let me just introduce 50-50 beam splitter. 50-50 beam splitter. 50-50 beam splitter. So it's an optical device, and let's say this is a 50-50 beam splitter. So if light incident on this, if light is incident on this beam splitter, then the light will divide it into two parts. Let's say this is the incident light, and with intensity I naught. So the incident light has intensity I naught, and then if it is beam 50-50 beam splitter, then 50% light will get reflect from this beam splitter. So this is the reflected light, and 50% light will get transmitted through this beam splitter. So this is the transmitted light. So intensity of reflected light will be 50% of incident light I naught, 50% of I naught. So this will be I naught divided by 2. That means whatever light will incident, then half amount of light will reflect from this beam splitter, and half amount of light will transmitted through this beam splitter. So intensity of the transmitted light will be 50% of incident light. So it will also be I naught divided by 2. So if it is there are also other type of beam splitter, which is called like a 30-70 beam splitter or 40-60 beam splitter. So for that case, the intensity of incident light, reflected light and transmitted light will be different. But if it is 50-50 beam splitter, then this whatever the light will incident on this beam splitter, it will divide into two equal parts. So half amount of light will be reflected from this beam splitter, and half amount of light will transmitted to this beam splitter. So in case of 50-50 beam splitter, the reflectance will be exactly equal to the transmittance. And to calculate this problem, I'm writing this reflectance transmittance is equals to alpha. And what is the definitions of reflectance and transmittance? Reflectance means the ratio of reflected light divided by incident light. So if you take the ratio of IR divided by I naught, what will get? Half. And also if you take the ratio of IT divided by I naught, will get half. So in this case, the reflectance and transmittance both are equal, and I'm taking it as a alpha. So in this case, alpha will be half. Alpha will be half. So what we're going to write there in this question, to when we will solve this problem, let's say this is a beam splitter. This is a 50-50 beam splitter. So this is a 50-50 beam splitter. Now, if a light is incident on this beam splitter with intensity I naught, then the intensity of reflected light and the intensity of transmitted light will we will write like this way. Reflected light will be alpha times into I naught, and intensity of the transmitted light will also be alpha times of I naught. What is alpha? Alpha is the reflectance and transmittance. In this case, for 50-50 beam splitter, it will be equal, and that value will be half. Okay, So value will be off. And whenever light will incidence on this beam splitter with intensity I naught, then the intensity of the reflected light will write alpha into I naught, and also the transmitted light will be alpha into I naught. Okay, so using this concept we can solve this problem very easily. So here is the figure that is given in the questions. So you can see here, first light will incident on the beam splitter 1 with intensity I naught. So when this light will passes through this beam splitter, so 50 alpha times I naught intensity will reflected from this beam splitter in this direction, and it will go to the detector 1, and remaining amount of alpha into I naught transmitted light, that will goes in this direction. So transmitted light will goes this direction, and the intensity of the transmitted light will be alpha times I naught. Now this intensity will reach to the second beam splitter. So for second beam splitter, the intensity of the incident light will be alpha times I naught. And again, here will also light will divide it into two parts. One part will transmitted through the beam splitter and it will reach to the detector 2, and another part will reflected from this beam splitter and it will go to the beam splitter 3. So what will be the intensity of the reflected light from the beam splitter 2? So it will be, in this case, from beam splitter 2, the intensity of the incident light is alpha times I naught. So in this case, the intensity of the reflected light will be this intensity into alpha. So it will be I naught into alpha square. I naught into alpha square. So now, this reflected light will reach to the beam splitter 3. So for beam splitter 3, the intensity of the incident light will be I naught alpha square. So when it passes through the beam splitter 3, then intensity will be I naught alpha cube, because for beam splitter 3, the intensity of the incident light will be I naught alpha square, and when it will passes through the beam splitter, then intensity will be this incident intensity into alpha, so it will be I naught alpha cube, and this light will goes in this direction and it will reach to the detector 3. And also same times there will be reflected light which will goes in this direction. So what will be this intensity? This intensity will also be, see, for beam splitter 3, the incident light is intensity of the incident light is I naught alpha square. So reflected light will have intensity I naught alpha cube. I naught alpha cube. Now this intensity will reach to the beam splitter 4. Beam splitter 4, and from beam splitter 4 again it will reflected back to the beam splitter 1. So when it will go to the beam splitter 4, and then it will reflected towards the beam splitter 1. So in that case, after beam splitter 4, the intensity of the reflected light will be this intensity. So for beam splitter 4, the incident intensity is I naught alpha cube. So reflected light will have intensity alpha to the power 4 into I naught. Alpha to the power 4 into I naught. Now this light again it will come to the beam splitter 1. Now for beam splitter 1, it will again split into two parts. One part will goes to the detector 1, and next part will come back to the beam splitter 2. So for the second case, so when this light will incident on the first beam splitter 1, so in that case the intensity of the reflected light will be I naught alpha to the power 5, and again this light will come to the beam splitter 2, and from there it will reflected back again towards beam splitter 3. So after passing through the beam splitter 2, the intensity will be I naught alpha to the power 6, and when it will passes through the beam splitter 3, then this intensity will be alpha naught into this intensity into alpha, so it will be I naught alpha to the power 7. Okay, I naught alpha to the power 7. So after second cycle, after first cycle, the intensity that will reach to the detector 3, it will be I naught alpha cube. And after second cycle, the amount of light that will reach to the detector 3, it will be I naught alpha to the power 7. So you can see here, after first cycle, the light that is reflected from this beam splitter 1, that intensity was I naught alpha to the power cube. Now this light will passes through beam splitter 4, beam splitter 1, beam splitter 2, and then it will passes through beam splitter 3 and it will come to the detector. So this intensity will passes through 4 times of this beam splitter. 1 times S4, 1 times S1, 1 times S2, and 1 time S3. So that's why each time we have to multiply with alpha. So when this intensity, again it will come back to the detector 3, by that time intensity will be this intensity into alpha to the power 4. So this intensity will be alpha naught into I naught into alpha to the power 7. So again you can see when this light will transmitted to the air, when this intensity, so same amount of intensity will also reflected in this direction, and again it will goes to the S4 and then it will come to the S1 and then it will come to the S2 and then it will come to the S3. So we'll get another term. So what will be the next intensity after next cycle? Next cycle intensity will be, this is the intensity after second cycle, and then we have to multiply with alpha to the power 4 with this intensity. So this will give you I naught into alpha to the power 11. So there will be infinite number of such circle, and if we want to calculate the total intensity, then we have to add it up all this intensity. So in questions it is written we have to calculate total intensity that will be measured by this detector 3. So in this case, if we want to write total intensity I3, so this I3 will be intensity after first cycle, that is I naught into alpha cube, intensity that will reach to the detector 3 after second cycle, that will be I naught into alpha to the power 7, plus intensity that will be reached to the detector 3 after third cycle, I naught alpha to the power 11. So on it will goes up to, we can write one more, I naught after fourth cycle, it will be I naught alpha to the power 15, and so on it will. So infinite number of cycle will continue. So the net intensity will be sum of this all intensity. So now you can see each term has this I naught, and alpha cube also you can take common. So what we'll get if we take common I naught into alpha cube common, then we'll get 1 plus alpha to the power 4 plus alpha to the power 8 plus alpha to the power 12, and so on up to infinity. So you can see this bracket term is actually a JP series, infinite JP series with a common ratio alpha to the power 4. Alpha to the power 4. So if we want to calculate the net total intensity that will be measured by this I3, so we have to take sum of this series. So what will be that value? What will be that value? You can see here. So this I3 will be alpha I naught into alpha cube, and then sum of this series. So this is an infinite JP series where the first term is 1 and the common ratio is alpha to the power 4. So the sum of this series will be 1 divided by this alpha is actually half. So alpha to the power 4 will be less than 1. So common ratio here is less than 1. So we can write 1 divided by 1 minus r. So in this case r is alpha to the power 4. Alpha to the power 4. So this will be the sum of this. This will be the net intensity that will be measured by the detector. Measured by the detector. So now if you put the all value of I naught and alpha, so we'll get the value of I3. So in this questions it is written that I naught is equals to 120. So put it 120 watt per meter square, and then alpha we have calculated is half, so alpha cube will be 1 by 8, and then if you put it here alpha, so it will give you 1 divided by 1 by 1 minus, so 1 minus 1 by 16. So if you simplify these things, what you will get? You will get 16 watt per meter square. 16 watt per meter square. 16 watt per meter square. So correct option will be option B. Correct options will be option B. So options B will be the correct. So in this case, the total intensity that will be measured by the detector I3, the detector 3, which is I3, and I3 value of I3 will be 16 watt per meter square. Okay. So by mistake, if you think that only there will be one cycle and the intensity that will be measured by the detector I naught into alpha times I naught into alpha cube, and that will give actually 15 watt per meter square, but that is not exactly the case. So here this will be the intensity after first cycle, but there will also be infinite number of cycles. So you have to, if you want to calculate total intensity, then you have to add up all these intensities after each cycle. So when you consider this infinite cycle, that's mean you have an infinite number of terms. So when you added this infinite number of terms, and finally you will get this answer, 16 watt per meter square. So I hope you understood it. So thank you for watching. We'll see you in the next video.